Alright, time to smash out this question on torque. An athlete in training holds a uniform rod, 2 meters long, stationary in a horizontal position. The mass of the rod is 3.0 kgs. Calculate the forces A and FB that are required by the athlete's hands to hold the rod in equilibrium in a horizontal position. Alright, the first thing that we should do is we should pick a pivot point. Okay, so the pivot point that I'm going to assign is FA. That's my pivot point. I'm going to use that because it's the easiest pivot point to gather distances from. Alright, once I've picked a pivot point, I need to understand that clockwise torques equal the anti-clockwise torques. This is why the rod is able to maintain an equilibrium horizontal position, okay? All the clockwise torques are balancing out the anti-clockwise torques. Now that I've understood that, I need to figure out from this question what are the clockwise torques and what are the anti-clockwise torques. Before I do that, I need to make sure all the forces are labelled on this diagram. So I've got the support force A, then I've got force B, and I've also got the centre of mass of this plank. The centre of mass, because it's uniformly distributed, we're able to have a centre of mass right over here, COM, and that is essentially 3 kgs. So from here, now that we have all of our forces labelled, now what we can do is we can figure out our clockwise and anti-clockwise torques in relation to our pivot point over here. So FB, around the pivot point, we see that if we were to keep turning from this upwards arrow, this would result in a anti-clockwise torque. What about the center of mass? What about this force? This force, if we were to continue allowing it to work around this pivot point, it would carry out torque in a clockwise direction. So now that we've established our clockwise torques and our anti-clockwise torques, we can fill that in to our table over here. So the clockwise torque that we have is our center of mass. Our anti-clockwise torque that we have here in relation to FA, our pivot point, is FB. This provides an anti-clockwise torque around the pivot point. The next thing that we need to do is we need to flesh out these equations, but we can't figure out torque without all the forces. So we're trying to figure out force B, okay, and force A eventually. And we've got our center of mass, but we need it as a force. So the way you work out force is F equals M times A. So the force provided by the center of mass is going to be 3.0 times 9.8, which is acceleration, and that equals 29.4 newtons. So that is the force of our center of mass, the plank. Now what we can do is we can just write a generic or a symbol equation for our torque values. So the torque equation for our center of mass over here, is going to be, let me write the torque equation here, T equals force times distance, is going to be the force of our center of mass, which we just worked out earlier, okay, times by the distance away from the pivot point, okay. Then the torque equation for our FB force over here is going to be the force of B times the distance of FB. Okay? And that is our torque equation for our anti-clockwise torque. Okay. Now all we need to do is plug in some numbers. So the force of center of mass is 29.4 newtons. Times that by the distance away from our pivot point. So we know that the full length of this plank is 2.0 meters. And our center of mass is halfway. So that means the distance from FA and our center of mass must be 1.0 meters, which is half of the full length. So distance is 1.0. FB, okay, the force of FB is what we're trying to figure out, times its distance from FA is 30 centimeters. 30 centimeters is not the correct conversion. We need to change it to meters, so we divide it by 100 and we get 0.3 meters. So the distance from the pivot point for FB is 0.3 meters. Now what we have to do is we have to rearrange for the force of FB. Now that we've fleshed out these torque equations for each component, we can start to solve. So let me rewrite this whole thing just so it's easy to follow. So we want this by itself, but currently it's attached to this times 0.3. How do we get rid of times 0.3? We have to divide this whole side by 0.3 to cancel out the multiply by 0.3. That means we have to do the same to the other side. So what we're left with is if the force of FB is equal to this. Plugging that into your calculator, you should get 980 newtons. Okay. And that's how we do it. That's how we work out at least one of the forces. We've done FB. What we have to do now is work out FA. So you could make FB the pivot point this time and then work out FA using the same procedure. But let's do it easier way. So we know the first rule that we've used is clockwise torques equals anti-clockwise torques. The next rule I need you to know is all the upward forces must equal all the downward forces for equilibrium in torque to happen, okay? So for this plank to stay horizontal and in equilibrium, we need all the upwards forces balancing the downward forces. So let's go ahead and identify our upward forces. FB, the force provided by this hand here, okay, FB is an upwards force. So let's add that to my table. FB. What about my downwards forces? We've got FA, which is a downwards force due to this hand, it's pushing down. And we've got the center of mass as well, which is a downwards force. So let's add that to my diagram. Kind of like the pink. FA plus COM. Now, time to substitute everything that we know. We know the force of FB, we've just worked it out to be 980, equals FA, which is what we're trying to figure out, plus the force of COM, our center of mass, which is 29.4. newtons. All we have to do now is we have to rearrange to find FA. So, how do we do it? Well, what we have to do, let me just rewrite this whole thing, equals FA plus 29.4. We want FA by itself, but currently it's attached to this plus 29.4. So to get rid of plus 29.4, what we have to do is minus 29.4 to cancel it out. So what we do to one side, we have to do the other. And what we're left with is FA equals 980 minus 29.4. So FA, according to our calculations, is going to be 950.6 newtons. So, based on the assumptions or our knowledge of the fact that clockwise torques equals anti-clockwise torques and our forces up must equal forces down for something to maintain equilibrium in a torque instance, we have figured out the forces provided by each hand. And so, well done. Hope that made sense. Let me know if you have any questions.